The topic we have for today is minimum and maximum points. We have a question here given that y equals to 16 over x squared plus x cubed over 3. Then we want to find the stationary value of y and then determine whether it is a maximum or minimum. Now, the stationary value or the value at the turning points is expected to be that when we find the first derivative of y, when we differentiate y with respect to x, at the y dx equals to 0, then the value of x we obtain becomes the stationary value. So what do? We say finding the y over dx is the first step. Now, how do we find the y over dx there? We are expected to rearrange this for better differentiation or for easy differentiation. If y equals to 16 over x raised to the power 2, it is the same thing as 16 multiplied by x raised to the power minus 2. And as such, x cubed over 3 is the same thing as x raised to the power 3 multiplied by 3 raised to the power minus 1. Then the y over dx is equals to 16 multiplied by minus 2 will give me minus 32. Then take 1 away from the power, it gives x raised to the power minus 3 plus the coefficient of x is 1 multiplied by 3, it gives me 3x. Take 1 away from the power, becomes 2, then multiply by 3 raised to the power minus 1. Now write it in form of fraction. We have the y all over dx equals to minus 32. X raised to the power minus 3 is the same thing as 1 over x cubed, and that will give me 32 over x raised to the power minus 3. Raised to the power 3 because we are taking the inverse of it, becomes x raised to the power 3. Then plus, this is 3x squared. 3 raised to the power minus 1 is the same thing as 1 over 3. So 1 over 3 multiplied by 3x squared will give me 3x squared over 3. So 3 can cancel 3 here. Then I will have my y all over dx equals to minus 32 all over x cubed plus x squared. Now, this is the stationary point. So to obtain the stationary value, then we are taking this y over dx to be equals to 0. So when that is taken to be 0, we have 0. We have a 0 equals to minus 32 all over x cubed plus x squared. Now, to solve this equation, it is best that we multiply all through by x cubed so that x cubed can cancel here. Then now we have x cubed multiplied by 0 equals to x cubed multiplied by minus 32 all over x cubed plus x cubed multiplied by x squared. So here it will be 0 equals to, this will cancel this, we have minus 32 plus x cubed multiplied by x squared. So we just take one of the base, x, then the law of indices, multiplication change to addition to be 3 plus 2, 5. So this is the same thing as 32 equals to x raised to the power 5. So from here, 32, for what value of, how can we express 32 of a number such that the number will raise to the power 5 to give us 32? We will see that 2 raised to the power 5 will give us 32. So equals to x raised to the power 5. So we can then equate the power. When we equate the power, then we equate the base. Then we are going to have our x equals to 2. 5 equals to 5, then x equals to 2. So the value of x is 2. So the stationary value of y is known to be what? To be 2. But we want to test whether it is maximum or it is minimum. It is believed that if the second order of the differentiation, that is the square y over the x square, if it is less than 0, then we say it is maximum. If the square y over the x square is greater than 0, we said it is minimum. But what if it is equal to 0? It is called the point of inflection. So if the square y over the x square, that is the differentiation of the first derivative, if it is equal to 0, it is called the point of inflection. So here now, we want to differentiate the first derivative again. So let's differentiate again. We are going to have if our dy over dx gives us what we have here, dy dx is this is what we obtain. We have minus 32 all over s cubed plus x squared. Now, we believe that this is the same thing as minus 32 s raised to the power minus 3 plus x squared. So let's differentiate it again. That's the square y over the x squared. And that's going to give us minus 3 multiplied by minus 32 is going to give us plus, this is 6, 9, plus 96, x. Take 1 away from the power becomes minus 4, plus 2 times 1, 2, x. Take 1 away from the power, x. So this is the same thing as 96 all over x raised to the power 4 plus 2x. Now, at this value here, let's substitute for the value. If x is equals to 2, what are we going to have at x equals to 2? I am going to have 96 over 2 raised to the power 4 is going to give me 16 plus 2 multiplied by 2 is going to give me 4, and that is going to be, by the time we cross it here, that's 6 is going to give me 10. So 10, is it less than 0? No, it is greater than 0. So we'll see that if x is equals to 2, then it is minimum. It is minimum because the condition says that if the differentiation, the second order derivative, if it is greater than 0, of course, then it's greater than 0, so it is minimum. Then we can obtain the value of y. So we say minimum at x equals to 2. Then we can now finally substitute for y and get the value of y at minimum value. So if y is equals to this, then when x is equals to 2, we have y equals to 16 over 2 raised to the power 2, 4, plus 2 raised to the power 3 is 8 over 3. Then y equals to, this is 4 plus 8 over 3. Then we say y equals to, this is 12, right? All over 1. This is 12 divided by 1. This is 12 plus 8. And that is going to be 20 all over 3. And this is the same thing as 6.67. Thank you.